Hello again. Today we'll be working on a 2-door GE refrigerator that is warming up in both the freezer and refrigerator sections. Temperature readings are 17 degrees in the freezer and 56 degrees in the refrigerator. The model number of this fridge is highlighted in yellow. In this unit, the freezer is what supplies the cold air to the refrigerator with a fan. So if the freezer is acting up, so will the refrigerator be. A freezer should never have any ice or frost buildup on the side walls or the back panel. And a quick peek inside the freezer reveals a lot of ice buildup on that back panel. Well, this definitely suggests that there is some sort of issue with this unit. So first, we'll shut the compressor off. To do this, you would have to increase the freezer temperature to the warmest setting. The display will read off upon successful shutdown. Next, we need to remove the freezer door. Warning says not to remove the hex screws. Yeah, we're gonna have to remove those hex screws to get the door off on both sides. After the hex screws are removed, the door will lift up, the bottom of the door will tilt forward, and the whole freezer door will pull off. Next, we need to remove all the shelvings, door slides, and the ice maker from the freezer. While removing the shelving from the freezer, I noticed there is a sheet of ice on the bottom of the freezer. Now this indicates a clogged drain line, so I'll take care of that issue for the customer as well. A clogged drain line is a very common problem in refrigerators that contributes to water's inability to drain out properly after a defrost cycle. This causes that water to leak out of the evaporator drain pan onto the bottom of the freezer. If this issue is not corrected, water will eventually build up into a sheet of ice and then start to leak out onto the kitchen floor. And if this leaky issue is not resolved, then the possibility of causing floor damage is extremely high, well, depending on the type of floor that you have. Both right and left door slides will have to be removed in order for the rear panel to be released. Each door slide will have 3 screws to remove. Pull the front of the door slide away from the wall and out towards yourself to safely remove the slides without breaking the 2 rear tabs. Next, we need to remove the ice maker. The easiest way to remove the ice maker connector is by using a pick. However, a flathead screwdriver and a bit more patience will also work. If the freezer was not cold enough when attempting this repair, then the ice maker will have the water in it and not ice. Be sure to have a towel aligned on the bottom of the freezer to collect the water that spills out of the ice maker. You can thank me in the comments section. 2 screws hold the rear panel in place. Remove them. Push the ice maker connector in through the quick access panel. Remove the quick access panel. And once the rear panel is free, pull the top of the panel away from the wall and the panel will come out freely. Any and all ice that is found on this evaporator coil will need to be defrosted. This will ensure proper frost buildup after the repair is complete and the refrigerator is reassembled. This bimetal thermostat is what we need to test. The bimetal thermostat is part of the defrost system and monitors the temperature of the coil. It will open to interrupt the defrost heaters from heating and close to turn the defrost heaters back on. And unfortunately, we will need to completely remove this thermostat from the fridge system to test it efficiently. The ideal testing procedure requires a cup of ice and water. While we don't have a cup handy for this repair, we have plenty of ice, so we'll make it work. Okay, so placing the bimetal thermostat into ice-cold water is simulating a frozen coil, so this causes the thermostat to close. Removing it from the water simulates the heating element raising the coil's temperature to the appropriate level, causing the thermostat to open. And by the looks of it, this bimetal thermostat is malfunctioning. The readings should be steady, but instead they are jumping. This indicates that the thermostat is constantly opening and closing, thus not allowing adequate power flow into the heating coil. This causes ice to accumulate on the evaporator coil, resulting in poor air circulation and consequently poor refrigerator and freezer cooling. After replacing this part, the freezer and fridge returned to normal working order.